Okay, and here we have another Punch-Out. This one is from, looks like JBK on the forums, and he was complaining of some video issues, and there we have it. We definitely have some video issues. What's interesting is that I believe the display draws in this section, and there's usually a black bar kind of on the top and the bottom. It actually looks like there's pixels being dumped to that space. I think that's like the blanking area or whatever you want to call it. But you can almost see, kind of like a little bit of the character kind of being drawn, his aura or whatever you want to call it there. CPU I believe is working because because of what I'm seeing here, and also I believe if I reset the game, let me do that here. I think you can hear audio. Yeah. So, and the audio CPUs, these two guys here, they get their cues from the Z80, which is there. So I'm pretty sure that we're in good shape. From a CPU PCB perspective, I suspect it's one of these guys, probably this guy here, the graphics one. Let's take a look at the top screen. Okay, so there's a clue. So the top screen is also, I'm sorry, that was the wrong button, that was the sound. That's the top screen, and it's doing the same thing. Now, the top screen gets I think all the logic for the top screen is actually on the back PCB. The middle PCB handles all the opponent and the player sprites, and it feeds that information onto the back PCB to be thrown on the bottom display. But the entire logic for the top display is also on this little PCB here. And so that's where I think I'm going to start, seeing as how we're seeing the same symptoms on both the top and the bottom display. And we'll start from this guy here and work our way back if we need to. Hopefully we won't have to move much farther than this guy right here. Well, after about 5 minutes of poking around, I already found something that's wrong. There's a signal called DMCS, which is a chip select that gets enabled during DMA transfers between the CPU PCB and this back PCB. And the first thing it does is feed into an inverter, and then from there it feeds all of this logic, okay, the front part of the back PCB, so that when we're trying to do DMA transfers, these buffers all get enabled, these muxes get enabled, so that the CPU board can talk to this board, alright? That signal is like non-existent. It's not doing anything. And we can kind of see that here. If I grab my logic probe, and we look at the input to that mux, which is pin 11, and move my finger so you can see, alright? So it's wiggling, that's good. And then the output of that inverter is doing absolutely nothing. It's tri-stated, which means it's not a high or a low, it's just floating there. And so this guy is bad. And so first step, let's rip this guy off, and then we'll see how things improve. Hey, looking better. It's the bottom screen, top screen. Uh-oh, do you see that? Okay, I saw that. We're almost there. Okay. So we're better. We're actually seeing some info here. This is the bottom screen, which looks pretty good. The top screen, not so good. Let's move over now. Glass Joe, let's see our player and opponent. Awesome. So, this is actually good news because we're still just restricted to a problem with the upper monitor. And that, again, is all on the back PCB. Now, there's some sketchiness with the characters being displayed and where they're being displayed, and so that tells me it's all in the RAM and the ROM area, and so that'll be my next spot to look at. But at least everything on the lower monitor seems to be looking pretty good. So let's go back to the drawing board. Let's go back to that smaller PCB, the back PCB. We'll poke around and see what else we can find. Well, as I was working on the board, I could see that the symptom actually changed a little bit. The top screen is no longer now showing random garbage. It's actually just filling up with black, and there's like a little bit of a glitching going on the side here. We'll let this play through. Actually, this is interesting. What I discovered in the schematics is that whatever is sent to the bottom screen can actually also be sent to the top screen. The data actually comes pouring up through here, and then there's a final mux up here that allows you to either drive the upper screen information or take some of the bottom screen information and dump it to the display. And that's why, like in the intro, we saw the two punch-outs, just different colors, and that's simply because the top and the bottom monitors have a different color palette, and so that actually saves a ton of space. You can take the sprites and the characters that are getting sent out the bottom display and send them out the top display. So the fact that I can see that in the beginning is a huge clue as to what's going on. I think it's in this section right here, this MUX, because it's allowing that bottom screen information to get sent through. You can see the Punchout logo, but the actual information that's supposed to be on the, the information about the characters and the power levels and all that stuff, that's kind of in here, and that's not making its way through. So I think it's that MUX. Actually, one cool thing is, like, if you drive that MUX intentionally, you can see, like, I'm looking at the top screen and I can actually see Glass Joe there bouncing around. Of course, his colors are off, but I just thought that was kind of cool. So anyway, I'm going to go take a look at this guy right here, that MUX, and I suspect that he is bad. Well, I took a look at this MUX, and it looks like it's doing its job. That is, it's taking the data and it's working its way through. This MUX basically controls the address that gets sent to the color prom. And the way it works is the color prom is broken up into a whole bunch of little banks, and each bank has 4 colors. And so you can see the lower 2 bits here, you can choose, either one of the 4 colors, comes from this character prom here, or character ROM rather. And the upper address bits go all the way down to a RAM, so that the game can choose which color bank it wants to use when it's displaying its characters or whatever. And so what I found is I hooked this up to my logic analyzer. Actually, I can show it to you right now because I still have it up here. So these are the least significant bits. These basically choose which of the 4 colors in a particular bank you want to display. And then these lower bits, they're actually the upper address bits that are down here. They just happen to be lower on my display here. But those dictate which bank you want to choose. And you can see that in like 99.9% of the time, and every once in a while you'll get a little something, but most of the time they're locked at a certain value. And so basically, we're supposed to be bouncing around through this color prom, picking different color banks and things like that, depending on how we want it to display on the screen, and it's basically getting pegged at one entry. Now this information comes all the way down here from a latch, but ultimately it comes from this RAM. And so as I was probing around this RAM, I'm seeing some funky issues with the enable to this RAM. And so just to kind of show you what I'm seeing here, with my logic probe, it doesn't actually show you, in real time, the frequency of these signals as they're bouncing around. It basically is just blinking if the signal is toggling, it's low if the signal is low, and it's high if the signal is high. So if I'm looking at VDD here, which is constantly high, you can see how it lights up, okay? And then if I pick ground, obviously the light will turn off. Now if I pick any other pin, that should be doing something. See how it's blinking there? Now chances are these other inputs are blinking at different rates. Let me pick a different input here. Okay, but you can see that the toggle pattern is the same. It's basically just like, it's like a 50-50 duty cycle there. Now one thing I notice is the enable signal that's getting sent over to that RAM for the color looks like this. And I don't know if you can tell, but it's like it's like flickering, almost like a light bulb that's about to burn out there. And so that's really suspicious because, like I said, this thing, if it detects anything that's toggling, then it should have, like a 50-50, meaning, it's on and off at about the same rate. And this guy here is just looking really sketchy. And so what I decided to do, actually I can do it here. I already threw some leads on here so that I can kind of throw this onto. Boy, this is hard to do with one hand. Well, let me see if I can do it. Come on, hold on. I guess I can't do it with one hand. Alright, there we go. So I got my oscilloscope here. This thing's also got an oscilloscope mode. And let's throw that on. Okay. And you can see here, this is my red signal. Alright. Every once in a while it'll kind of float up, but for the majority of the time it's doing nothing. Okay. And so that guy doesn't appear to be doing what it's supposed to be doing. So let me yank him off, and then we'll see if that improves what's up here. Ah, okay, that's better, much better. It looks like I'm actually picking the wrong color banks from the color palette, because these colors look off and I'm missing some characters. Yeah, exactly, okay. Yeah, I'm missing some detail on the eyes and stuff, and so I suspect that I'm just picking a wrong color bank. And so I'm going to fire this guy up again, and I'll look at the address bits and see if maybe one of them is tied high or low. I think we're getting access now to our RAM, and I suspect that maybe one of the outputs is somewhere in the data path from the RAM over to this MUX. One of the address lines is probably tied high or low. It wants to select, a certain color bank so that it can get the detail in it, but it's being forced to, choose a different color bank, and that's why we're losing some color here and stuff. And colors are completely off actually. So I think I'm going to do that. I'm going to probe those address lines there and see what's going on. Ta-da! Looking good. Took care of that last issue with the addressing to the palette ROM, and we're in good shape. Let this play through a little bit, see if we get our detail back. Alright, very nice. So I think this one is good to go. I'm going to let it play through a little bit and check out the sound and some other stuff there, but video issues are looking good. Let me see if I can reach over here and just double check again the lower monitor. There we go, lower monitor looks great. So yeah, we are all set with this one.